Light is only created from accelerating particles. There's actually a very simple argument for why this is the case. Now we've got a paper that says gravitational waves do exist.
Right.
Okay? Just like electromagnetic waves.
Yes.
Okay. And just like electromagnetic waves, in order to create gravitational waves, you need accelerating bodies. So you can't have a thing that's just moving at constant velocity.
Because it's not going to disturb
Because
the
it's
space.
not going to disturb space in the way that it propagates out.
Yes.
Okay? It's going to create a disturbance, but that disturbance is just going to like sort of be local to it.
Yes.
Okay? And you're not going to get this like radiating effect.
It's like if you're in a boat and you're stationary, you don't create a wake. But if you're moving...
But in a boat, even a moving boat creates... This is a big... this is a fine detail. A boat that's moving at constant velocity is still going to create waves.
Yes, that's fair. That's fair.
A charged particle that moves at a constant velocity will not create a light wave.
Interesting.
Light is only created from accelerating particles. So something that's moving in a circle, that is going to create a radiating effect. Something that's speeding up or slowing down is going to create a radiating effect. But something that is moving at a constant velocity is not. It's one of my favorite arguments from Einstein's special relativity, okay? So suppose not, right? We're going to do this by a proof of contradiction. Suppose not. Suppose that a charged particle that moves at a constant speed does create light. What if I were to boost myself into a reference frame that I'm moving with the charged particle at a constant speed? In my reference frame, that charged particle is stationary.
Yes.
So I'm not going to see any light. But now there's a contradiction.
Yeah, right. Immediately. Got it.
Immediately there's a contradiction. Because a stationary observer observed light, but me moving with this particle does not observe light. It would be something if the stationary observer observed a particle with some light, and I observed it at a different energy, right? Maybe it was like boosted in ultraviolet or down in infrared or something like that. But the fact that I observed no light is unphysical. Because both me and the stationary observer should observe the same physics. Right? So it's a consequence of relativity that constant velocity motion does not radiate. The same thing happens with gravity, right? Suppose there's a gravitational object that's moving at a constant velocity. If I boost myself into that reference frame, that object is now stationary, and I shouldn't observe any gravitational waves. On the other hand, if it's accelerating, if it's moving, it's speeding up or it's slowing down, then no matter what inertial frame I choose, it's also going to be either speeding up or slowing down. So I am going to observe some form of gravitational radiation, or in the case of charged particles, some form of electrical radiation, light. You know, that's kind of...